Hi. So we discussed about refraction and Snell's law. So Snell's law states that ratio of sine of angle of incidence to sine of angle of refraction is equal to refractive index of second medium with respect to the first medium. It is equal to n2 by n1, and when we are substituting for n2 as c by v2 and n1 as c by v1, we will get it as v1 by v2. So refractive index, absolute refractive index is different for different value is different for different medium, and here I have given some values. For air it is nearly equal to 1, so 1.003, or it is nearly equal to 1. Water it is 1.33, glass it is 1.52, it ranges from 1.4 to 1.5 for glass, and diamond it is the highest, that is 2.42. So there is one normally one more question which can be asked from this part is the refractive index of diamond is 2.42. What does that mean? That means the speed of light in um, the diamond. So refractive index is 2.42 is equal to c by speed of light in diamond, or we can write speed of light in diamond is equal to c by 2.42. So it is 1 by 2.42 times speed of light in air. So that is speed in diamond. And depending upon the value of refractive index, we call the medium. As for example, if light is passing from air to water, here the refractive index of air is less, refractive index of water is more. So we call the first medium which is having the less refractive index as the rarer medium, and water which is having a more refractive index as a denser medium. And if we are just think that it is passing from glass to water, so it is passing from a denser medium to a rarer medium. So which is having less refractive index, we call it as rarer, and which is having more refractive index, we call it as denser medium. So here now we are going to see when light passes from rarer to denser medium, and also when light passes from denser to rarer medium, what will happen. So first we will see refraction when it passes from rarer to denser medium. Okay, so here we are taking a rarer medium, any medium, rarer medium and a denser medium. So this medium, first medium is having a less refractive index, and second medium is having a more refractive index. So when light passes from a rarer medium to a denser medium, so this is the incident ray, and we have to draw the normal to the point of incidence. Now the actual path of the ray should be like this if there is no medium, but as it is passing from a rarer to denser medium, the speed will be more, and denser medium, when it passes to a denser medium, its speed decreases, and because of that this ray will bend towards the normal. This angle is angle of incidence, this angle is angle of refraction. This ray will bend towards the normal when it passes from rarer medium to a denser medium. Now just think that the reverse happens. So now we are going to pass the light from a denser medium to a rarer medium. So here we are taking denser medium, here we are taking a rarer medium, and the light ray. Here, this is the normal to the point of incidence. So when a light ray passes from a denser medium to a rarer medium, denser medium the speed will be less, and a rarer medium the speed will be more. So it will bend away from the normal. So, when a light ray passes from rarer to denser medium, the light ray will bend towards a normal, and when light ray passes from denser to rarer medium, the refracted ray will bend away from the normal. So, this you have to keep in mind. Okay. Now, we are going to see if a light ray is passing through a glass slab. This experiment we will do in the lab. Okay, so here I'll just draw what will be the path of the ray. There we will do with the help of some push pins and glass slab. We will mark the incident ray, we will plot the refracted ray and the emergent ray. Okay, so first I'm going to take a glass slab, a thick glass slab. So let this be a glass slab. A, B, C, D. Now at this surface, I am going to make an angle of incidence, an incident ray is falling. So this is passing now. This part it is air, from air. This is the glass slab. So a thick glass slab. So this medium is glass. So you know that air is a rarer medium compared to glass. Refractive index is less for air compared to glass. So it is passing from rarer to denser medium. So at the point of incidence you have to draw a normal. Now the actual path should be like this. If the glass slab is not there, it should pass like this. But here what will happen is that as it is passing from rarer to denser medium, it will bend towards the normal. This is the angle of incidence. This is the angle of refraction. Now, at this surface, it is passing from glass to air. So, it is passing from a denser medium to a rarer medium. So, at this point of incidence also, we have to draw a normal. Now, as it is passing from a denser medium to a rarer medium, it will bend away from the normal. So, the ray will go like this. And this angle we mark as R itself, and this angle we mark as E. This is known as angle of emergence. The ray with the angle with which it comes out of the glass slab is known as angle of emergence. These two angles will be equal because these normals will be always parallel to each other. This one and this normal are parallel. So these two are known as alternate interior angles. These are equal ones. So this is I, this is E, and you can see that these two rays, that is incident direction, and this emergent ray, this ray is known as emergent ray. So this incident ray and the emergent ray are parallel to each other, and this distance between incident direction and the emergent direction is known as lateral displacement. So lateral displacement means it is the distance between incident direction and the emergent ray, incident ray and the emergent ray. So emergent ray is shifted by a small distance compared to the incident ray, and that distance is known as the lateral displacement. And this lateral displacement will depend upon the angle of incidence. So if you are increasing the angle of incidence, this D value also will be changing. And also it depends on the thickness of the glass slab. If you are using another thickness, glass slab which is having a different thickness, this lateral displacement will be changing, and it depends on the material also. Different types of glasses are there, so it depends on the material by which it is made. So these are the factors on which the lateral displacement depends. First factor is that it depends on angle of incidence. Second one is that it depends on the thickness of the glass slab. Third one is that it depends on the nature of the material. So that is about refraction through glass slab. Next we have to learn about refraction through spherical lenses, and that is another big topic. Just like spherical mirrors, we have to learn ray diagrams for spherical lenses.